Hello folks, well it's Easter Sunday and I've got 40 minutes before my first church service this morning as an organist. So I thought we'd get on with this set out of box 29. So the last set we did was the Realistic 1002 from box 28. We've got another set to do from box 28. The second set in that box is a Realistic 1001. But I thought we'd skip that for now. It's Sunday. 29 is a box with two items in. Kindly, this one is a Colt 295A. So I'll just jot that down. Now he sent with it a Colt microphone, but whether it came off a UK FM Colt or whether it came off something which had been illegally imported, I don't know. It came with no mic plug on it, and I've just spent 10 minutes putting one of our metal mic plugs on. It's a little bit short. I'd like to have put a new lead on, but we can't get new leads. Yes, I can get an old one from a retailer, but I need to be able to buy them in bulk, and I can't. Except 3 metre long ones. So it's March 1982, so it's later, and we'll come to that because it's the A version. The serial number is 0001970. It's got a power connector, which is helpful, although we do manufacture the leads for these and have those connectors available. Maxon chassis. The only two Colts we saw was this and the 355. So there are two versions. There's a 295 and 295A. Here's the front of a 295. I bought some fronts off eBay some years ago, and that shouldn't have a 4-pin mic socket. And someone's actually penciled out. They love modifying things, don't they? They really do. That's why they end up as scrap. So if I've just got a bit of isopropyl alcohol left, let's see whether we can clean what this says. There we go. It's RF gain high-low. So the early version, like the Midland Precision series, hadn't taken into consideration the early version of the MPT 1320 UK specification. They hadn't taken into consideration that it was going to be a requirement for high-low power. So sets got manufactured without that feature. So RF gain high-low power on the early version, and then correctly on the 295A that was sorted out and it was power high-low. So there you go, that's the difference between the two, and that 4-pin mic socket shouldn't be there. So we'll put that back in the bucket of fronts. Never seem to have a front for a set I want though. So we'll connect this up to our crocodile clip leads because I'd like to try it as is. Power supply on, and it powers up with a meter lamp. There we go. So connect up the test equipment. I'll keep an eye on the time. We don't want the headlines of the local paper. Organist doesn't turn up for Easter Sunday service. I've got no audio on receive. Now why is that? because the wires might. How can the wire be? How can the mic be wired backwards? You know what's happened in here. So I've wired the mic correctly at the business end. The whole reason I did it off video was to save time, so we had a fighting chance of actually getting this done today. So we have a situation, put the soldering iron on, the red wire so the screened wire is quite correctly, of course, the transmitted audio. It's the yellow one, and the black wire should be receive and the red wire should be transmit, but somebody's put it the other way around, and that's why when I've wired the mic correctly to the colours, it's the opposite way round. I would have thought that the mics with these being Maxon would be the flimsy Maxon mics that the inserts have now failed in 40 years later. So I suspect, but I'll have to look at old advertisements. I think this probably came off a set intended for another country. That said, it does say made in Korea on it, which fits in with Maxon. Right. I didn't say I could put it back together either. Switch back on. Now we have transmit and receive. Right, so what I was going to do before being interrupted by that problem is to check the PA. Testing 1, 2, 3, 4, 5. Wallow. And as usual, disappointingly it comes through both speakers because it wasn't thought through at the factory. Right, back to normal. And what we'll do is we'll tick that off. So straight away we can say the meter lamp's okay, and the PA functions are okay, the mic's okay. Let's have a look at some of the other stuff. So we'll switch picture in picture on. There we are. Is it on the wrong camera? It probably is. Let's just check. We should be on camera 1. We're on camera 1 now. So transmit, we'll start on the 3 watt scale, and it just goes across. It's 3.1 watts. 3.1 watt. Well, that's a nice start. Channel 40. It's 3 watts. And channel 1. 3.1. So low power, we'll go back to channel 20. and on low power it's doing 390 milliwatts. That's fantastic. Back to normal power, and the current is 1.027 amps. Well, we soon went through that. Deviation. Wallow. Wallow. It's 1.5. And the VCO we're not going to be doing because you have to add extra components. I've explained that one before. One day we'll get a set with the VCO problem and we'll add the extra components. 2779076. Just pop that up a bit when we get there, and let's set the signal generator to the same frequency so we can have a fair test of the receiver. I'm sure you see what I'm doing. If I put the signal generator on the correct frequency of 79125, then it would be an unfair test because the radio isn't on that frequency. Right, is there any receive? There is. I'll switch the cyanide meter on and we'll put camera 4 on. There we go. So for 12 dB we've got 0.98 microvolts, which is actually inside the spec of normally working. 10, 0.82, and 20 if it does it, is not bad, 2.4. Turn the squelch to full, see when it comes in, show you the attenuators. So we're parked at 0 there, so 3 microvolts, 10 microvolts, 30 microvolts, 100 microvolts. I want it to come in at that. 300 microvolts, 1 millivolt. It's far too tight. Sensitivity of squelch. We'll put the signal generator standby. Set the squelch threshold on the radio. Switch the signal generator back on, and it's 0.78 microvolts, which is excellent. So when I press transmit, it's bang on the 4, which will be different when it's actually doing 4 watts. And on the signal generator side, put 100 microvolts on, and let's see what the meter says. It says 5. Let's see if we can ever get it to read 9. We can, and the signal needs to be 1 millivolt, which is what you call a lazy needle. It may not be adjustable on this, really doesn't matter. We know the sockets work. Good. So we'll open it up. Oh, it's sealed. Ooh. Well, I'm glad it's sealed. Is this one of these eBay absolutely perfectly working sets? Should be yellow to the right, but it makes no difference. It's not like it's stereo, is it? So can't see anything messed with in there. Can't see any dodgy capacitors. You know, everything looks fine. So we'll start with the transmit tune-up. So go back to camera 1. And we'll go through this stage. You can can see the VC has never been played with, so yeah, I'm not going to have to add those extra parts to do that. So we're at 3.1, we're still at 3.1. Still at 3.1. This is all spot on so far. It's now dropping, it's about 3 because it's warming up. This looks like candle wax. About 3.3 there. Oh, it'll just do it. Let's just see. Go back on that one. It's 3.1 at that. Sorry, 4.1. What am I talking about? So we'll drop it by turning that clockwise. So now that's 4 watts. Right, channel 40, 3.95, channel 1, 4.05, back to channel 20. Current consumption is now 1.099, so being correctly tuned, it's not drawing much more current to do nearly a watt more. So, what, less than 900 milliamps? 90 milliamps? Can't be bad. So now we'll look at low power. Switch that to low power, and it's doing 420 milliwatts. So I'll just adjust that, like that, adjust. A little bit dirty that, I'll just give that a quick spray. Spot on now. 400 milliwatts. Wallow. Wallow. There we go. That's now 2.2 to 2.5. Let's see where the meter can be put now. Oh, we're on low power, aren't we? So we're back to high. So that's now banging across, so with the back one of those. I've got the curl of the mic lead. So that's now bang on the 4. And remember, when you have this on an aerial, it'll be totally different reading. It may be 1, it may be banging across. It doesn't mean it's doing less or more power, it'll still be doing 4 watts, but the meter is affected by the SWR and all that. So we'll do the frequency. That's about 4 watts. Hopefully it'll go. So we'll go over to the frequency counter. It's starting to be off frequency enough to be noticed, but not enough to be illegal. Tell you what, it's gone, hasn't it? 27 now, 79126. I was going to start to think it wasn't going to quite make it. Good. Let's see whether we can improve the receiver. We'll start with the detector, go over to the oscilloscope, switch the bench light off, put an S9 signal on the signal generator, and turn the volume up to give myself a reasonable waveform. It's one of the types of sets that the detector coil does drift on. But in this case it's absolutely spot on. So we'll go to the synod meter. And we'll attenuate it for about 4 dB there on the synod meter. What an improvement. Let's go back to that. Drop the attenuator again. Oh, hang on, you know what? I haven't reset the signal generator. So let's go back to the frequency counter. I'm going to start again. Now the radio's on frequency. It shouldn't affect those, but it could affect the detector. Okay, so we'll now go back to the oscilloscope. Put 100 microvolts on and make sure we're still at peak. We are. Four dB on the meter. These shouldn't be any different. But these could. We'll put a bigger signal on for those. That's definitely peak. It's funny, you know, the IF's spot on this. It's the front end ones which were out. It probably gains a little bit just there. Right, we'll get a new reading. So for 12 dB, we now have 0.72 of a microvolts. For 10 dB, got now 0.62. I'll tell you what, I'll put it back on the synod meter. And for 20 dB, no, 1.7. Good. Well, I'm pleased about that. So, going back to an S9 equivalent signal, see if we can adjust the meter to be S9 instead of the S5 it's on. And on this version, there isn't a preset for that. And I don't want to, I'm dead against modifying sets like this because some sets have and some sets haven't, and you've lost the history when you start messing like that. So that is absolutely as it should be, therefore. See what it does now read. I expect it's still 1 millivolt. It is. Squelch. So put the squelch to full. I've now selected 100 microvolts on the signal generator. Here's the squelch preset. Well, want it to come in at some point. So on maximum sensitivity, it won't come in at 100 microvolts where I'd like it, but it does come in at, let's tell you, so we're at, that's 100 microvolts, 150, 200, 250, it's coming in at 300 microvolts. There's nothing wrong with that, but I personally like them at 100. Right, so now we'll do the sensitive end. So that's threshold set on the radio, signal generator back on. Coming in at 0.68. And just for the record, let's see what we can actually hear this receiver down to. So we're gonna put that's 1 microvolt, that's 0.3. Change the tone. It's easy to hear. I can hear it right down to 0.06 as far as the attenuator goes on this test set, so it's not deaf by any means. Well, that's it, folks, we're done. So the switches work fine, the potentiometers work fine, so we brought the power up, we brought the receive up. Well, that's a nice radio. Let's put the lid back on. I'll just go and look at the time. Can't afford a clock in here. Now, I like those. That's not the right lid. I like those rugby clocks, you know, which are on. Is it MSF? The radio controlled ones, and there is one in here, and it's on a daft shelf, and it fell off the daft shelf into a pile of scrap chassis. So one day I'll pull it back out, and the trouble when these things fall off shelves, they usually spill the batteries out as well. Mark's coming during the course of this week, so better make sure it's a bit tidier. I can see why they seal these things, because we do know there's people out there who will steal parts out of sets. So it's not a matter of whether the set's tuned to perfection. It's a matter that you're going to end up with expensive parts missing. We'll put this on the aerial and its own speaker. And so it's the Antron 99, Solarcon 99, Cadbury's 99, One Anna Roger. One Anna Roger. Now look how clear that is on Easter Sunday morning at 9 o'clock. I think they're all getting ready to go to church. That must be it. Right, so there we are. We'll do an on-the-air test later on with this. Thanks for watching the Colt 295A.